Welcome back to my online tutorial. In today's class, we have a nice looking Math Olympiad problem. Now let's look at the solution together. Now we have an if statement here. If s plus 1 upon s is equal to the square root of 13, we have to find the value of s to the fifth power minus 1 upon s to the fifth power, where s is a set of real numbers. Now, as you can see, this is an Olympiad problem which require critical thinking and sound logical reasoning. So we have s plus 1 upon x equal to the square root of 13. And we are going to find s to the fifth power minus 1 upon s to the fifth power. And if you look at the if statement there, that's a quadratic equation. Any attempt for us to solve this quadratic equation and plug in the value, or rather the values of x into this expression, we are going to run into a brick wall. Hence, we have to, be very logical. Now, the first thing I shall do is taking the if statement. We have s plus 1 upon x equal to the square root of 13. Now, we have a radical on the right. So if I square both sides, this is what I'm going to have. Let me take this off my solution. Now, squaring both sides is going to help. Number one, is going to help me undo this square root or the radical. Now, bracket open s plus 1 upon s bracket closed all squared can be written as s plus 1 upon s in one parenthesis, s plus 1 upon x another parenthesis equal to the square root of 13 squared. Now, I have to distribute. I will use x to distribute this parenthesis and use 1 upon x to also distribute this parenthesis. Now, s multiplied by x is s squared. S multiplied by 1 upon x, that's going to give us s over x. Now, I will take 1 upon x to multiply x, that's also s divided x. I will take 1 upon x to multiply 1 upon x, that will give me 1 upon s squared. Now, the square root here, we undo the square. So we are left with 13 on the right. Now, s divided s is 1. I'm going to be having s squared plus 1. S divided s is also 1. I have 1 plus 1 upon s squared equal to 13. Now, 1 plus 1 is 2. I'll try to take s squared and 1 upon s squared together. So s squared plus 1 upon s squared plus 2 equal to 13. I will now subtract 2 from both sides. That will give me s squared plus 1 upon s squared equal to 11. This is equation number 1. Now, as you can see, from what we have got here, I shall be able to figure out the next step. It means that if I have s squared plus 1 upon s squared, I need to go find a way to look for s cubed minus 1 upon s cubed. Then I will go into algebra and look for some formulas there that can help me solve this problem. The first one I shall look is the square of difference. Please note this English, square of difference, not difference of two squares. Now, if we have bracket open a minus b bracket closed all squared, we can write this one to become a squared minus 2ab plus b squared. So I can rewrite this to become a minus b all squared. This square of difference, that will be a square plus b square minus 2ab. This is a well-known binomial formula. Now, from our expression here, s plus 1 upon x, it means that a is equal to s and b is equal to 1 upon x. Therefore, a minus b all squared will give us s minus 1 upon s all squared. That will be equal to Here I have a squared, which is s squared, then plus b squared, 1 upon s squared, minus 2 multiply ab. A is x, b is 1 upon x. That will be 2 multiply x multiply 1 upon x. So as you can see clearly, as we cancel out s here, we only have 2 left there. So we now have s minus 1 upon s all squared. Here becomes s squared plus 1 upon s squared minus 2. So you can see the creativity and the logical thinking, we are putting into this problem. Now, from equation number 1, s squared plus 1 upon s squared is equal to 11. So I will then write s minus 1 upon s all squared. That will be 11 minus 2, and that is equal to 9. So s minus 1 upon s all squared equal to 9. So to undo the square here, I shall take the square root on both sides. So I will now have s minus 1 upon s equal to 3. Now, I will consider the negative value, because once you take the square root, you're supposed to have plus or minus the number or the variable. Now, the reason why I'm not considering the negative value is because of the statement here where s is a real number, so s cannot be negative. So I will leave this as equation number 2. Then that's not enough. I told you my objective, after being able to get s squared plus 1 upon s squared, I should be able to get s cubed minus 1 upon s cubed. So I will go to another binomial formula again, cube of difference. Here we have square of difference. Here we will have cube of difference. Now, a minus b to the power of 3, if you expand it, it's like saying this a minus b we have here, multiply another a minus b. That's going to give us a cube minus 3a squared b plus 3ab squared minus b to the power of 3. So if you expand this, you can also use Pascal triangle. This is what you are going to have. Now, I will take a cube and b cube together, then factorize these two middle guys here. So I have to take this off. Then if I do that, I'm going to be having something, I have to clean it up so that it can be clearer. So I will have a minus b cube. That will be a cube minus b cube. Then like I said, I will factorize this pair. Then I'll bring out minus 3ab. I will now have a minus b. So if you distribute this, you get this expression back. It's a fantabulous question. Then, as usual, we plug in. A is equal to x, b is equal to 1 upon x. So s minus 1 upon s to the power of 3, that becomes s to the power of 3, which is the value of a, minus 1 upon s cubed, which is b to the power of 3. 1 upon s to the power of 3 will give us this, minus 3 multiply x multiply 1 upon x into s minus 1 upon x. That's what we are going to have. So as you can see here, s will cancel out. So we have s minus 1 upon s all cube. This will give me s cube minus 1 upon s cube minus 3 into s minus 1 upon x. So we have done extremely well. At this stage again, we look at equation number 2. S minus 1 upon s is equal to 3. So we plug that here. We are going to be having 3 cube equal to s cube minus 1 upon s cube minus 3 into 3. So you can see here in this parenthesis as well, we have s minus 1 upon x, which is equal to 3. So as you can see, our homecoming is guaranteed. So this is 27, this is 9. So 27 equal to s cubed minus 1 upon s cubed. That will be minus 9. So if I isolate these two guys, s cubed minus 1 upon s cubed, I will add 9 to both sides. That will be 36. I will call this one equation number 3. Now, as you can see, like I said from the beginning, we've achieved one of our primary objectives. I've been able to get s cubed minus 1 upon s cubed, which is 36. From equation 1, we have s squared plus 1 upon s squared equal to 11. So what I will do, I will say multiply equations 1 and 3. Multiply equations 1 and 3. That's what we are going to have. Now I'll go up here, take out these guys. So equation 1, as I recall that, I know is s squared. Equation 1 is s squared plus 1 upon s squared equal to 11. This is equation 1. Then equation 3 is s cubed minus 1 upon s cubed equal to 36. Equation 3. So if I multiply them, I'm going to be having s squared plus 1 upon s squared in one parenthesis, s cubed minus 1 upon s cubed in another parenthesis. That will be equal to 36 times 11. That's what we have. Now, if I distribute the two parentheses, I'm going to be having s squared multiply s cubed. That will give me s to the power of 5. Then s squared multiply 1 upon s cubed. That will give me negative s squared upon s cubed. I'm done with this. I will use this. 1 upon s squared multiply s cubed. That will be s cubed on s squared. Then 1 upon s squared multiply negative 1 upon s cubed. That will give me negative 1 upon s to the 5th power. And this is equal to 396. 36 times 11 is 396. So as you can see, our target is s to the 5th power minus 1 upon s to the 5th power. Our solid thing. So s to the power of 5 minus 1 upon s to the power of 5. Here, I will use s squared to divide s cubed. S cubed is x multiply x multiply x. Then I will use s squared to delete 2 x's there. I will be left with 1x. Then here, I'm using s cubed to divide s squared. I'll be left with negative 1 upon x. This is equal to 396. Now, from equation number 2, I also know that s minus 1 upon x is 3. Then I'll write s to the 5th power minus 1 upon s to the 5th power plus 3 equal to 396. Then if I subtract 3 from both sides, s to the 5th power minus 1 upon s to the 5th power, that will be equal to 393. That's our final answer. So if you subtract 3 from both sides, that will be 393. So this is the final answer to this problem. So like you can see, and like I said, it's an interesting question, a very fascinating one that requires critical thinking and logical reasoning. We've come to the end of today's class. I guess you enjoyed it. Continue to like, share, and watch our videos. See you next time. Bye.